Hi, my name is Brett, and today I'm going to be doing a quick demo of the Quickdistill library. Um, Before I really get into how to use the library, I just want to clarify what the use case is for this particular library. Basically, this is for scenarios where you have existing traces from a model, usually a sort of a strong model, such as like GPT-5, um, and you'd like to find sort of an alternative model that's maybe cheaper, faster to run. Um, and usually these are use cases where you've got like a very large workload, but you've already ran the model on a few samples of what you may see. So this could be something like you want to summarize a lot of documents, and maybe you have 100,000 documents to summarize, um, and maybe you've done it on 100 documents with GPT-5 or something like that. And the goal is basically to find the best model that sort of approximates your existing model while also being cheaper and maybe even faster. So I'm going to walk through how to use this library. First thing is just to install it. So you can install it with pip. Make sure to install the latest version. And then we can run the quick distill launch command, which this will launch in our browser. And you'll have to make sure and set your Weights and Biases API key because it uses Weave, as you can see in the terminal. So you'll see here. So once it launches here, you'll see I've already loaded up some of my traces from a project. So it's in order to basically load your project, you just type in your project and then fetch, and that will load up basically all traces for your project, and you'll show up here. And this trace viewer kind of looks like a sort of like an expanded version of what you see in the Weave dashboard. So basically for this project, this was for like a LLM as a judge project. So I've got traces basically prompting the model to rate a response based off some criteria, and you can see I've got lots of traces here that I ran using GPT-5, and we can filter just by the certain GPT-5 model. You can see here that we've got 199 traces for this particular model, and they all show up here. So basically what this entire project is based around is LLM as a judge. And it doesn't necessarily have to be LLM as a judge, but that's the main scoring system that's supported right now. And what I like about it is it's pretty simple to use, and it's very quick to define judges. So I'll kind of show the different judges that we support just right out of the box. The first one is just like a Boolean judge. So basically you define a prompt where you pass in the original output and then the outputs from your alternative models, which I call them weak models. You can also call them like alternative models. And you basically just ask the judge to say, are these two responses basically the same? And you can customize this prompt depending on basically how you want to compare the responses. And then there's other scores that you can do, like a scalar score one, which basically you're saying, okay, given these two responses, give a score of how similar the weak model output is to the strong model. And then also we've got ranking responses. So say you've got multiple models that you want to compare against the strong output. So say you've got GPT-5 output and you want to compare like GLM 4.5 and GLM 5, say. You can actually prompt a judge to rank how well the two responses compare to the strong output. And there's a couple different ways you could do that. You can either do sort of like a single shot, or you just ask the model to respond like basically an ordering of the best responses. You can also do like a round robin ranking system, so you can basically compare each individual response up against each other. So if you've got like say 5 or 6 models, you can compare each one against each other and sort of tally up their results. It's kind of like a round robin tournament. Um, so there's several different judges that you can use, and you can customize like the base model. This supports open router models, um, and customize the prompt. Um, and that's how you basically create judges. So after you've created a few judges and you've got some traces, um, we'll just go ahead and do like a simple evaluation of pretty much comparing a few different models. So I'll select the traces that we want to do. So I'll just select all these traces. There's about 199 traces here, and we'll click this end-to-end test. And we can select different models. So for this test, I guess we can select GPT OSS 20B and maybe Llama 3.1 AB. So you've got these two models, and I'll get to this later as far as selecting different prompts that you can use. This library also has support for sort of selecting in-context examples that you might want to use to sort of improve the performance. And you can also run multiple examples in parallel to speed it up. So we'll do it on 10 examples with 5 parallel workers, and we'll just use our scalar scorer here, which is going to basically rate the model's outputs in comparison to our strong model traces, which we selected earlier. So yeah, so we can go ahead and run this. And the first thing it's going to do is it's going to run inference with the alternative models. So that's GPT OSS 20B and Llama 3.1 AB. And then once it gets done running the two models on the same inputs that GPT-5 saw, it's going to run our judge and basically score the outputs in comparison to the strong output to see basically how well that did. So here the evaluations are done. I'll go ahead and open these up in a new tab here. So here you can see we've got our 2 evals, which we can select them and then just compare them. And here we see the results. Here we see that looks like GPT OSS, no surprise here, outperformed the Llama model. And also interesting, at less cost as well. That's probably due to similar pricing. And actually, it might be cheaper pricing. I'll have to check on this. Looks like more tokens on average, but lower cost, which is surprising. And we can also look through the outputs here, and we can see our score, how it performs. So yeah, so that's basically like kind of like the simple use case. And there's another interesting feature here that I mentioned earlier that we can select in context examples that may improve their performance. And one of the ways you can do that is actually by mining the examples. So you run an eval, and you basically find the responses that the model generated that a judge deems to be the worst in comparison to the strong output. And then you select a subset of those to use as your in context example. And you can use just a few, or you can use even several. But at the same time, you have to keep in mind that as you add more examples, it's going to burn more tokens and be more expensive. So that's kind of a trade-off that you have to keep in mind. But this library kind of makes that a little bit easier to manage. So in order to mine some examples, I'm going to select my Llama model here. And we'll use 5 workers again, and we're just going to look at like 20 examples in our data set. And these are the same traces that we selected earlier, and we're going to use our same score, and we're going to start mining here. And so this is going to look at several examples, and we're going to, in a second here, we're going to see a screen basically showing sort of a distribution of how the model did on the data set. So that way we can kind of look through and decide which examples we want to use for our in-context examples, which will be our prompt, essentially. Okay, so see here we have this distribution of answers, and it looks like about 8 out of the 20 examples that we saw were under a score of 3.0. So 8 kind of sounds like a fair amount of examples. We're going to go with just 5 examples that we're going to filter out. And we can just simply export these examples. So we can call these hard. We can export these, and you'll see here a button that we can just go ahead and click to actually build a prompt with these examples. So if you want to click that, you can. I'm just going to go here and click Prompt Builder. And here you're going to see this screen that right now we haven't really loaded any data, but we can go up here to the top and we can load our mined examples here. And what this does, you can see down here, it loads up those 5 examples that we just selected. And here we've just, by default, it adds like 3. But we can load the first 5 traces in here and basically combine them all into one prompt. And you'll see here there's like this big kind of system prompt which repeats itself several times, which for a prompt you really only need this once. So there's basically like a feature here that you can select, which it will just leave the first system prompt and then strip it from the remaining examples. And you can see here there's a token count. This just uses the GPT OSS tokenizer to give you some idea of how many tokens are in your prompt. Here, if you click cost calculator, you can sort of get an estimate of what this in-context prompt will cost you. So if we click here, estimate cost, it will show the list of weights and biases inference models and basically the cost to do 100 examples with this prompt. And we use just like the average input and average output of our traces to do what's basically the tokens in addition to the system prompt. So you can see here for something like GPT OSS, it'll be about not even a penny, almost a penny. And we go here to Llama 3.18b. I'm just curious if this is actually. So yeah, it actually says it's around 3 cents to do 100 calls. So GPT OSS is actually cheaper than Llama, which I wouldn't have guessed before doing this, but it turns out it's true. So now that we've basically built this prompt, looks like we've got all 5 examples selected. We can give this prompt a name, so we'll call it Llama 3.8b hard, and we'll just say 5 examples. And we can save this. And this will actually save inside Weave as well, so it'll save your prompt inside Weave. So yeah, so now that we have saved this prompt, we can go back and we can try to see if this prompt actually helps our system. So we can go back to run end-to-end test. We'll select Llama 8b. It looks like I've actually already saved from my previous run. And for one of the models, we can add our prompt. So right here, I've got a model without the in-context examples and one with the in-context examples. And we will run our score. And I'm going to increase the number of examples because our system actually, underneath the hood, basically tracks our in-context examples that we use, because We obviously don't want to evaluate the model on examples that it has in the prompt, so we make sure to track that in the underlying evaluations that are going on. So it's just going to skip any examples that um, are in the data set. So you won't get sort of false results because of your prompt. So yeah, so we can go ahead and run this. And this will take just a second. Alright, so now the evaluations are finished, and we can open them up inside Weave. So we go here to evals, and we will select the two evaluations that we just ran. And you can see here we've got the model with our prompt and without our prompt, and we can see here that we improved the performance by a little bit using the in-context examples. However, that does increase our cost quite a bit here. So you can see here that the cost is about 4 times higher with the in-context examples, which makes sense because we had about 5 examples. So yeah, so basically you can do this type of thing. You can do it at a much larger scale. So, you know, if you wanted to test out basically all these models, you can just go through, select them, and if you want to try out different combinations of examples. So if you want to build a prompt with 3 in-context examples, 10 in-context examples, and then basically just run large-scale evaluations, you can do that really quickly, and you can also get an understanding with Weave of the costs that you're going to incur. So yeah, so I hope you enjoyed this quick start guide. If you have any feature requests or ideas, I definitely like to hear them, because I think we're kind of at a point where I'm sort of out of ideas. I need more feedback on what would be good for this. So thanks for watching, and I hope you have a good day. Thank you.